Okay, this time we're going to be looking at distance problems. And so we're going to start first of all with the very basics of distance. And it's the distance formula. So we're going to have distance equals rate times time. D stands for the word distance. R stands for rate. And rate is things like miles per hour, kilometers per hour, meters per second, things like that. That would be a rate. And T is the time it takes. And if we have hours up here and minutes down here, usually we have to make them the same, okay? So, as we look at this, the very simplest form of these problems is one vehicle or one item going at a fixed rate. So let's look at something very simple, such as my car is going 75 miles per hour, and I drive 3 hours. How far have I driven? Well, 3 times 75 is what it would be, because this is my rate, this is my time. So I just simply multiply the two together. 15, carry my 1, 21, 225 miles is how far I have driven, okay? Now, if we wanted to know how far our friend drove, and they drove 3 hours at 50 miles per hour, they would have 150 miles. So, how far have we driven together now? Well, 225 plus 150 is going to give you 325, 375 miles is how far we have both driven. So on that day, I drove 225, she drove 150, so together we came up with 375 miles. So this is taking simple and then making it more complex. So as we look at distance, there are actually 3 ways that we handle distance. And I'm going to work with those, each one, explain them all, and then we're going to look at problems that use those various formats. The 3 types that we're going to have. The first one we already did, the sum of the distances. We're going to add them together, okay? The second type is we're going to look at a subtraction of the distances. And the third type is going to look at the distances are equal to each other. Okay, so those are the 3 types that we're going to look at on these problems. So let's look at them. The sum of the distance. If 2 people leave one place going in opposite directions, the distance of this person and the distance of this person is going to equal the total distance. This one is done with 2 different things. We can do it either going away from each other, or we can start in 2 different places and drive towards each other. But it still is the same type of a formula as that one. So this is the distance of the first one plus the distance of the second one is equal to my total distance. Okay, that's type 1. So now let's look. Oh, and there's certain distinctives of this. They leave at the same time. They also either go in opposite directions or away from each other. And you're usually looking for a time. How long does it take them to meet, or how long will it take them to get that far apart? So that's type 1. Okay, so let's look at type 2. Type 2 has them leaving from the same place, one going one speed, the other going a faster speed. So you're looking at the distance in between the two. So this would be D1, this would be the distance 2, and so you're going to have D2 minus D1 is going to give you the distance in between. And they're usually asking how long will it take them to get that far apart, or how long will it take, what will it be? So that's, again, another one that you're looking at time. So what are the distinctives of this one? You leave at the same time. Another distinctive, one drives farther and faster. And they'll often use the words distance between, or possibly distance apart. So those are common words used on that, and the distances are subtracted. Whereas the first one, the distances were added. Okay, type 3. In this one, either you have somebody going and coming back, or you might have one person leaving and the other person leaving later and catching them. So in both cases, those two distances are equal to each other. So you have distance 1 and distance 2, distance 1 and distance 2. This is a go-come situation. In your go-come, your distinctives are go and come. In other words, go to my mother's house, come back from my mother's house. Different rates are often involved in this, but they're based on each other, and the other differences is different times. So this has a lot of differences to it, different times. And since it's a go-come, you're not going to be at the same time or anything. Whereas this one, your distinctives are the second catches the first. Okay? And they have different rates and different times. So as you see, this third one is very distinctly different from the others. All right? So let's go over these 3 examples again. The first one, the first type of example, is the two distances are added to each other because they're either going apart from each other or they're coming towards each other to meet in the middle. And they leave at the same time, and the distances are added, and you find out how long it takes that to happen. My second one, we're looking at both leaving at the same time, but one goes faster, farther, and they want to know what is the distance between the two. Leave at the same time, distance between, so your distances are subtracted, okay? Because you're going in the same direction. It's always the same direction on these. Okay? This one over here, the distances are equal to each other because you're going, one is catching the other, or it's a go-come situation where they have different rates, different times. One of the types you're catching, and the other is a go-come. Okay, so now let's look at some example problems, that match these three types, okay? Okay, here's the first problem. Two cars leave St. Louis. Going in opposite directions. Okay, the minute it says going in opposite directions, what does that tell you about this problem? Well, this already tells you it's going to be a type A problem, right? Because that's the only one where they went in opposite directions. And it says they're leaving at the same time. Again, that's part of type A. One drives at 65 miles per hour. The other drives at 75 miles per hour. So if we were to draw a picture, here's St. Louis. One goes one direction, the other goes the other direction. One is going 65 miles per hour, the other one is 75 miles per hour. Okay? How long? There's that key word, how long, looking for time, will it take them to be 840 miles apart? In other words, they're going to get quite a ways apart, 840 miles apart. So what we want to know is our time. Remember, your distance is rate times time, and their time will be the same because they left at the same time. So my distance for my first person is 65. T is going to make up their distance, plus 75t makes up this one, and that's equal to 840 miles apart. Add these two, and you're going to have 140t is equal to 840. Divide by 140, and we are going to get t is equal to 6 hours. Now, we can do this in other ways. We can do this with a chart. If we were to do it with a chart, I would have the person number 1 at 65 miles per hour, person number 2 at 75 miles per hour, and my total distance is 840 miles. Then I would do it by trial and error. My time I'm going to put over here. If I drive for 1 hour, 65 times 1 is 65 miles, 75 times 1 is 75 miles, 65 plus 75 is 140 miles. That's a long way from 840, isn't it? Well, let's jump up more than 1. Let's try 5. 5 times 65 would be 25 carried by 2, 32, 325 miles. 5 times 75 would be 150, 375 miles. And 325 plus 375 would be 600, 700 miles. Well, I notice right here, 840 is only 140 more than 700, and 1 hour is 140. So 5 plus 1 gives me 6. 6 times 65 is 390. And 6 times 75 would be 450. add these two together, and I get 840 miles. So by trial and error, we came up with 6 hours. So we can do it either algebraically, or we can do it this, okay? Now, take this same information, and what if I wanted to know what would be going in the same direction, and how long will it take them to get 840 miles between them? So this is a different picture. If they're going to go in the same direction, we're going to have this kind of a drawing, 75 times t and 65 times t. And again, 75t minus 65t equals 840 miles. Same information, just a different direction. And now you're going to have 10t is equal to 840, and divide by 10, so it's going to be 84 hours, because they only gain 10 miles apart every hour. So it's going to take a long time to get 840 miles apart by this particular one. So that's using that same information, but doing it a different style problem. So that's a number 2 example. Okay, now let's look at one more example. Okay, this one says, John leaves the office at 7:30 a.m., traveling at 55 miles per hour. Okay? Now it says, his wife found he forgot an important paper and needed to catch him. So she followed the same route, traveling at 65 miles per hour. Okay? So his wife leaves the office, and it says half an hour later, so 30 minutes later, and she is traveling at 65 miles per hour. And the question is, at what time will the wife catch John? Okay? At what time will the wife catch John? So he left first at 7:30, so the wife would have left at 8 o'clock. But anyhow, we need to figure out how long it's going to take to catch. Remember, if you're going to catch it, the two distances are equal to each other. So, what do we have here? This one's going to go, and this one's going to catch him. So their distance is the same. John is going 55 miles per hour. The wife is going 65 miles per hour. If we say John's time that he's going to be caught is t, then the wife's time is t minus 30. And we can go ahead and leave it as minutes. Why? Because you'll have miles per hour cancels out because of the equality on this case, okay? So this time they're equal to each other. So we have 55t is equal to 65 times t minus 30. So 55t is equal to 65t minus 1,950, because 65 times negative 30 is 1,950. Subtract my 65t from both sides. and I will end up with negative 10t is equal to negative 1950. Divide by negative 10, and I have t is equal to 195 minutes. Why? Because my 30 is in minutes. So my miles per hour canceled, and I ended up with minutes. All right? So, how many hours is that? Well, divide by 60 minutes per hour, and we end up with 3 hours and 15 minutes. Why? 160 times 3 is 180. 195 minus 180 is 15 minutes. So, what are we going to do? Well, he left at 7:30 in the morning. So that's 7 hours and 30 minutes. Plus 3 hours and 15 minutes. So what's that going to give us? Well, 30 minutes plus 15 minutes is going to give us 45 minutes, and 3 plus 7 is 10 hours. So they're going to catch each other at 10:45 a.m. Okay, those are the 3 types of problems, and we give you 3 examples, so you've had an example of each one of the type of problems you're going to see in your homework. Have a good time at it. I hope you enjoy yourself. I think these problems are a lot of fun.